Progress with challenges on South Western Railway. Indian Railways has a glorious history of 150 years. In recent days, it has demonstrated remarkable turnaround in its performance, both in physical and financial terms. This re-engineering through several path-breaking innovations is a case study material at various leading business schools across the world. South Western Railway, established in 2003 with Hubli as its headquarters, is a jewel in the crown of Indian Railways. South Western Railway covers areas with fascinating climate, dense forests of Western Ghats, and several unique places of tourist interest, including World Heritage Sites. South Western Railway is a forerunner in providing services to the rapidly expanding iron ore mining, steel industry and power plants of this region. The freight operations from Hospet, Bellary to Madgaon Port via Hubli, Londa, Castle Rock through Braganza Ghat section to Madgaon Port is not only a challenge, but calls for the application of highest engineering skills. This is a living proof of South Western Railway's focus, vision and mission objectives. The movement of goods and passenger trains from Castle Rock onwards till Kulem is a technical challenge of huge proportions. The construction of this railway track has its beginning in the year 1878 and is a fascinating piece of history. The tussle of imperialistic hegemony of the British and the Portuguese in their Indian colonies often took shape of a trade war, and the movement of goods was of major importance to both the powers. After much arm twisting and negotiations, both the British and the Portuguese entered into a treaty to build a railway line to connect the British-occupied territory of Castle Rock to Portuguese Vasco. The WIPR, that is, West of India Portuguese Guaranteed Railway Lines, came into existence in 1878. Steam engines ruled the tracks. The liberation of Goa in 1961 brought an end to 4 centuries of Portuguese rule, and WIPR was handed over to the Indian Railways. Even today, the fumigation shed built at Castle Rock by Portuguese stands witness to history. This shed was an entry point to the Portuguese territory, where all the border crossing formalities were completed. In January 1997, the entire section from Castle Rock to Vasco da Gama was open to traffic after conversion from meter gauge to broad gauge. This has brought about a breakthrough in the economic growth and industrial development of Goa.
The fortunes of South Western Railway are linked to the 2 ghats, Castle Rock Kulam and Sakleshpur Subramaniam Road. Inasmuch as that the freight potential of this railway is determined by our ability to run trains through these ghats, which provide connectivity to the ports. We have, over the past 1.5 years, brought about a complete metamorphosis in the working of ghats. The ghats are old, but the manner in which we are running trains today is very new.
The picturesque Braganza Ghats, measuring 26.8 kilometers in length from Castle Rock to Kulem, has 16 tunnels, the longest being 410 meters. The splendor of Dudhsagar waterfalls next to the Ghat section track is a true visual feast. There is a serving station named after the falls. There are 70 curves, having a maximum curvature of 7.4 degrees. Slip slidings are provided at the Vasco da Gama end, downsides of the gradient at Karanzol, Dudhsagar, Sonaliam. The only catch siding is provided at Kulem. The movement of trains in this Ghat section is an operational marvel indeed. The main breadwinner of South Western Railway is iron ore traffic. In addition, it earns by transporting coal, fertilizer, sugar, rice, POL, steel products, cement and agricultural produce. From the loading pits of Hospet and Bellary, 59 wagons of iron ore load are drawn by 2 WDG4 locomotives up to Castle Rock. As the train requires a greater power to move into the hard sections, 3 additional WDG4 locos are attached in the front. These new generation WDG4 locos are the main workhorses of the South Western Railway. Initially imported from electromotive diesels and now manufactured indigenously, they are the finest that traction engineering has to offer today anywhere in the world. Under a technology transfer contract with the American company of EMD, these locomotives are now being manufactured indigenously at the Diesel Locomotive Works at Varanasi. These locomotives are equipped with a turbocharged 16-cylinder 2-stroke 710 GB diesel engine. The engine has very high fuel efficiency and requires low maintenance. It has many modern features like laser-hardened cylinder liners, unit fuel injectors which eliminate problematic HP tubes of the older design, Inconel valves, hydraulic valve adjuster. The diesel engine drives the main alternator. This main alternator converts the mechanical power of diesel engine into alternating current. This AC to AC transmission has the advantage of high adhesion and high tractive effort. Matching 3-phase AC traction motors of high reliability, availability and higher energy efficiency convert this raw power into high levels of traction and speed. This WDG4 loco, with its 4000 HP, is capable of starting greater trailing loads at gradients than comparable locos with much greater horsepower at their disposal. The passenger version of the EMD locos is christened WDP4, which is capable of hauling a 24-coach train at a speed of 110 km per hour and shorter trains at Rajdhani speeds. Recent upgrades on this modern locomotive have enhanced the horsepower to 4,500 and have made them even better suited to haul heavier trains, the need of the day.
These locomotives have the main advantage of extremely high tractive effort, very good dynamic braking and controllability. Not only train operations are safer with these locomotives, they are also more economical for the railways because these locomotives are more fuel efficient, they require fewer locomotives and hence fewer number of crews. So these locomotives are not only given us better traction, better train operations, better safety, but also cheaper operations and more economy.
The Master EM2000 computer on WDG4 and WDP4 locos interacts with the traction computers, air brake computer and other loco equipment and controls the entire loco operations. It enables troubleshooting through fault archive display and guidance system. And all these continuous technical upgradations are aimed at minimizing human intervention. These locos, when in formation, act as a single unit. These computers have the capability of configuring nearly 2,400 parameters. The synchronization of all the 5 engines is fully automated. Every loco has an event recorder of all the important details of movement and engine outputs for the past 72 hours. After a security check of loaded train, the 3 engines taxi is attached. Earlier, 8 Alco engines of WDG3 type with a formation of 3 at the head, 2 in the middle and 3 at the rear used to move the train up and down the ghat section. This was an operational nightmare. As the section is only a single track, this resulted in a lot of time consumption, breaking up of loads, attaching and detaching complications. Because of this, a lot of rakes were piling up at Castle Rock Yard. The introduction of 5 WDG4 engine formations has brought in a revolutionary change in the speed and frequency of goods train movement. This streamlining through the help of new generation locos has resulted in absolutely zero waiting period at Castle Rock Station, and the yard is clear of waiting rakes. This new change in operation came into being in August 2007, and the statistics speak for themselves for ever-increasing throughput on this section. South Western Railway is the proud owner of maximum number of WDG4 locomotive fleet in India, and these locos represent the future of diesel traction on Indian railways. The maximum speed of WDG4 is 110 kph and WDP4 is 160 kph for Shatabdi and Rajdhani. At Castle Rock, the train gets ready for negotiating the critical section of Braganza Ghat. This is an elaborate safety check procedure. The train undergoes a complete mandatory checkup of various parameters and gets recertified for traffic worthiness. As a routine procedure, this certification is done at the originating station. But an en route station like Castle Rock has a compulsory exercise of rigorous safety recertification by a dedicated troop of experts. This is a must before the train leaves Castle Rock and begins the descent. As the loaded train arrives at Castle Rock, some of the important inspections that are undertaken are fuel check and refueling. Only nominated locos fitted with AEB system are permitted. AEB system ensures the train comes to a halt once it crosses the permissible speed. A fully loaded train is almost 5,500 metric tons, and the heavy momentum down the hill may result in a runaway train. To prevent this, the AEB, or the Auto Emergency Braking System, is activated at Castle Rock, and the guard secures the key before it moves down the ghats. The system automatically operates at a predetermined speed of 30 kmph for a goods train, 40 kmph for a passenger train while descending, and 40 kmph for all ascending trains. The governing speeds for moving down the ghat is 30 kph and 40 kmph upwards. During the initial movements, the brakes are checked at low speeds of 10 to 15 kmph, and this is called the field test. The anti-roll back braking system is a unique feature of these engines, and this prevents a runaway train not to roll back from the sidings. The loco computer senses the intended direction of the train, and if the train rolls back in the wrong direction, it applies the anti-roll back brakes to prevent a catastrophe. New generation EMD locomotives are controlled by 6 onboard computers, and the whole regulation system is checked using laptop computers. The EM2000 gives lots of inputs to the drivers and maintenance staff. It provides diagnostic services when something goes wrong. The MIS output of microprocessor-controlled WDG4 locomotives can be used for identifying stretches of track that are coming under stress and consequently faster wear and tear. Based on such feedback, suitable directed track maintenance can be taken up. All the locos have dynamic braking system. Dynamic brakes are electric in nature and are applied without the brake shoe coming in contact with the wheel. The traction motors work in reverse as generators, and the electrical energy thus generated is dissipated in a resistance grid. The traction motors experience a reverse reaction torque, and the train is braked. The EMD loco dynamic braking is sophisticated enough to bring the train to almost a complete stop, close to a standstill. This system of braking saves wear and tear of wheels and brake shoes, prevents heat generation in brakes, and enhances their life.
मैं अजीत कुमार सावलन के लास्ट 3 महीने से मालगाड़ी चालक के रूप में हॉस्पिटल रंजीतपुरा सेक्शन में काम कर रहा हूं। दूसरे लोगों की अपेक्षा कंपेयर करने पर G4 लोको बहुत ही अच्छा है। इस लोको का डायनेमिक ब्रेकिंग बहुत ही पावरफुल है। लोडेड गाड़ी भी मैक्सिमम डीबी में रखने पर 30 से 40% गाड़ी कंट्रोल में हो जाता है। कंपेयर करो तो कन्वेंशनल लोको के अपेक्षा इस लोको का ऑपरेशनल फंक्शन भी बहुत ही अच्छा है।
Adequate brake power is ensured for all trains going up and down the ghats. The incoming loaded rake is examined for brake power and fitness for working in ghat sections. Wheel slip and consequent power loss is a major problem when heavy loads are hauled. This limits the amount of tractive effort we can gainfully apply to the train before the wheel slips. To prevent this, proper grade of sand which is stored in the station is filled in the sand boxes. The sanding nozzles are tested before the train begins its journey in the ghats. The tracks of ghat sections are regularly checked and maintained by dedicated staff. After all these safety checks of various parameters, one more confirmatory safety certification, Confirm En route check, is issued. This procedure itself gives a hint of the enormity of operational challenges and dangers in negotiating ghat section tracks. Loco pilots with adequate seniority are selected and their working in the ghat sections are intensely monitored. The extreme conditions in which loco pilots work can lead to considerable stress. The earlier running rooms were poorly equipped and lacked even basic amenities. To provide better facilities and a true resting place to the loco pilots, modern running rooms have been built. These are designed by professional architects and constructed with modern construction material. All new running rooms have facilities like restrooms, kitchen, dining hall, recreation center, and meditation room. Loco pilots, after refreshing here, are all set to move the wheels of the nation once again.
Naziruddin A. Bijapur, working as a senior loco pilot goods at Castle Rock. Moving of goods trains from Castle Rock to Kolam down the Braganza Ghat section and from Kolam to Castle Rock up the Ghat section is really a great challenge for us. I am proud to be a loco pilot of this Indian Railways.
Keeping in tune with technology, a computerized crew management system has been introduced for even distribution of crew working and rest hours. Booking is done on a first-in, first-out basis for the first period and on the basis of cumulative duty hours in the second fortnight. Loco pilots, after reporting and undergoing set rules and formalities, collect the caution order and board the locomotive. The freight operations on South Western Railway are among the most difficult on Indian railways. It is an overwhelming sight to see a train of 58 or 59 boxen wagons being hauled from Castle Rock to Kulem and back from Kulem to Castle Rock. All down-the-ghat trains are worked, therefore, with 5 WDG4 locomotives deployed in the front of the formation as 2 consists. 1 TLC leading, followed by 1 MU. Each consist is worked by separate crews. All the down-the-ghat trains are stopped at each of the stations for 2 minutes before starting. This helps in the controlling of the trains. The WDG4 triplet of a down-the-ghat train is cut off at Kulem. The train with the original 2 locos continues its journey further towards Goa. The trains coming from Vasco are stopped at Kulem. The brake van of the rig is detached and 1 WDG4 triplet, or TLC, is attached in the rear for banking the formation up the ghat. The banker is used up to Castle Rock and is detached there. Brake vans are moved light from Kulem to Castle Rock for balancing purpose. Goods trains are not allowed to follow a passenger train down the ghat, and passenger trains are not allowed to follow a goods train up the ghat as additional safety measures. To facilitate training in the field of maintenance and operation of EMD locomotives, a unique training facility has been created, which consists of an elegant training school equipped with loco components display rooms, seminar room, faculty room, loco propulsion system, EMD loco simulator, and a cozy training hostel to provide accommodation to trainees. The training center is also provided with latest training aids like projection system, audiovisual room, OHP, etc. to ensure that interactive sessions are made to give more meaningful training to the trainees. Staff from other zones of Indian Railways is also being trained here. Indian Railways is always committed to safety in train operation. As training of loco pilots is very crucial in overall safety in train operations, the Railways decided to procure a loco simulator, where simulation of full scope, full motion, real-time train driving under real situations is imparted. The simulator cabin is networked with the instructor and observer stations. The instructor, who monitors the performance of the trainees, can actuate the simulator, apart from generating a series of real-time situations for enabling the trainee driver to get different types of driving techniques. Such a system ensures the most realistic assessment of the loco pilots in the areas of locomotive driving management, driving behavior on various situations, knowledge on different important troubleshooting techniques. In addition, the training center is also procuring complete power pack of the diesel engine, which the trainee would be able to disassemble and reassemble, and in the process learn all the important design and maintenance features.
Myself, Deepak P, working as loco pilot at Hospet Depot. Yes, we have been given a much better training of a fortnight regarding this WDG4 locos. We have the well-trained faculty at EMD shed who are trained us in operating the locos and troubleshooting the problems encountered, which are much better, have much better facility as compared to the conventional locos of troubleshooting.
The loco shed at Hubli was constructed specially for the maintenance of 4000 HP WDG4 and WDP4 locomotives. The shed is spread out in an area of 50 acres, with a total covered shed area of 2,600 square meters and 1,700 square meters of administrative buildings. This state-of-the-art administrative building has direct access from the building to the repair bay, with excellent visibility of the complete shed. the pioneering efforts of Diesel Loco Works and Hubli Diesel Loco Shed in acquiring, assimilating, and disseminating the state-of-the-art technology will go a long way in bringing Indian railways at par with advanced railway systems of the world in diesel traction. Today, South Western Railway serves its customers through 375 railway stations located in 3 divisions of Hubli, Mysore and Bangalore, and a team of 45,000 employees, including officers. South Western Railway runs about 250 freight trains and 260 passenger-carrying trains every day. The network of South Western Railway spans 3,105 route kilometers. South Western Railway contributes significantly to the iron ore export of the country. And among the various zonal railways carrying iron ore for exports, South Western Railway occupies a proud position. To achieve these operations on Castle Rock Kulem section becomes all the more important. With the motto, "We care, we serve," the staff and officers of South Western Railway are rededicating themselves to create the finest network on the Indian railway system, to bring about progress and prosperity in the region and the country.